Hey there, welcome back. It's the second video of this series. So if you haven't yet watched the first video, which is like the introduction and motivation, then you just need to go back one step away and just watch it. So you just have to watch that video to be able to understand what I'm going to be doing in this video. So just an introduction and motivation for you. So if you're completely new to Android, then go back there. So if you have like prior knowledge on Android and you're already knowing what the Android framework is, or you are a developer or something like that, then this video is for you. Yeah, so in this video we're going to be talking about security and how you are going to be routing the device or the AVD that you will be working on to practice on how to reverse engineer those little applications on your phone. So yeah, so that's it. So before we start the video, as usual, don't forget to follow me on Twitter. So don't forget also to follow me on the different social media platforms that you can find about me. And don't forget also, I think, just that sub button too, which is really important. Yeah. So I guess it is time just to dive into this like Android security like model, see like how this framework is going to be securing itself, because like so far like we've covered like the basics of the Android app development. Like we touched on some important aspects of the Android framework like layers as we have seen in the previous video. Like, however, like there is something that we haven't dived into the critical details on how these apps are working exactly and how they are protected. So these two like aspects of the app development and the security, I feel like they are like linked in a hard way. So yes, they are linked too much, and we cannot separate them together. So this video is going to be about understanding like some security, I think, about the Android that the Android set up for itself, or what the Google team has did. So yeah, so we're trying to see this part. So this picture, so I'm going to be just showing you some models from the Android documentations directly, so you can understand exactly what the security is. But before that, I need to talk about some things, and we need to be also like understanding, some stuff. So for example, like guys, the first question is like, have you ever like wondered how those applications on your phone are actually working, and specifically how they are securing themselves while running? So these questions like are really really important to start this, like, how do we say this little research that we are doing together, to be able to understand each answer. Yeah. So as it turns out, like the answer to this question specifically, how these applications are secured on its own way, is actually through actually within the Linux itself, which is this one. So the Linux operating system will serve as the brain of the phone, like controlling what to run, how to run it, and ultimately like determining the behavior of the phone itself. Yeah. So like it's the final layer in the Android framework, and understanding it is really crucial, guys, to unlocking like the how do we say this, like the full potential like of the device itself. So like to start, like it's important like to understand, guys, that when an application is launched inside of this operating system, which is the Linux operating system. When the application is launched, we refer to it as a process, which is something you've already know, I think. So this term like will be frequently used like a lot in our discussion that we are going to be doing today, and like just to ensure like the security of the Android system, each application just would run on its own like process, like with its own unique Linux user ID. This is really important. So for people who do not know, like when you try to run a process, it's going to be linked to an ID. And this ID is going to be actually the one that will be responsible for identifying the user that is going to be running this process. Like for example, when you have like your Linux system running on your computers, so there are some processes processes that are going to be using your username. For example, let's say your username is ironbyte, so it's going to be using ironbyte as a username, and some other like processes which are, for example, system processes, are going to be using the root. So the root is has more privilege over ironbyte, for example, as a user. So this is just a simple example. So it's the same thing that goes in your phone. Some applications are going to be using some specific ID, and some others are going to be using some other IDs. So this means like that the Android framework, guys, is going to be creating a new Linux user for each application installed on your phone, and each application has its own private directory, let's say, like commonly known as the internal storage, which is something that we will be talking about later on, which cannot like be accessed by other application. And if an application can access the internal storage of another application, then this is a vulnerability and it should be reported, which is something that we will try to see. For example, if we can like apply that on some example of applications in the next videos when we start practicing. We try to finish the theory, then we go back to practices to fully understand how this Android is working, and to fully like have the knowledge. Yes. So like as we have like talked about, so this technique as that I'm talking about, which is each application is having like its own user ID, we'll make sure that we are doing something which is called the sandboxing. So sandboxing is making sure that the application runs on its own on its own space. And as you can see, like in the picture, like application A and application B are running on both the stack, but there is a separation when it comes to the Linux kernel. Yeah, especially like both of them are running on the Linux kernel. Both of them are using like the high level like layers of the stack that we have seen for the Android, but there is some security boundaries that should be respected, which is like the kernel will make sure that, well, the Linux specifically will make sure that those boundaries are respected. So yeah, so the first thing I can just explain to you like quickly what sandboxing is for people who do not know. Like sandboxing is a way or a technique. Why is, for example, the first question that, for example, a newbie can ask about sandboxing or something that do not know what sandboxing is, like, why the hell do we even have to use such a technique? So you can imagine, for example, the sandbox as a way just to make sure that you can just, I don't know, like, what is the best example to explain such a thing? Let me think. Yeah. So for example, you can just, for example, in the sandbox, you can build. We can take the example of sandcastles. Yeah, when you go to the beach, for example, you have sandcastles, you create tunnels, and you play with your toys. But there is like one rule that says you can only play with your own toys, like in your sandbox. Like your fans have their own sandboxes with their own like toys to play with, but now let's think like about the applications on your phone. Like each application has its own sandbox, just like you have your own sandbox, just like, I don't know, you have your own toys and all of that. Like this means that the app can only access its own toys. So, or in the case of the application, we are talking about data and files. So it cannot access any other application data or file. Just like the same way you can't play with your friends' toys in your sandbox too. So this is important, like because it helps keep your phone safe. It's if one application gets a virus, for example, or is being hacked, it can't like spread to other applications because each application is on its own sandbox. So it's like having like a boundary around each sandbox just to keep the sand inside of the toys separate. So it's quite nice, like right as a technique, but it's still not impossible to let them communicate. But under some constraints, we will talk about them later on, guys, like in the next videos. There is some ways to do that. Like anyway, so this communication occurs through like the low level mechanism, like we call it like a binder. If you are like remembering the indents in the first video, like the binder is a low level mechanism that is going to be helping us do the communication that we have talked about. So the binder will just serve as as the man that will do the communication between the application and is essentially like an inter like process communication mechanism, which is the IPC. If you go search about it, like, or the yeah, the IPC, and you have to go and understand exactly what the IPC is. So it's just a simple, yeah, inter process communication. That's it. So now, if we take a look at the at these security boundaries that we have talked about, like sandboxing is one of the few things that we should be like caring about. So yeah, so this is just a picture to illustrate what I was talking about, which is the user ID, so that each application is going to be having each Linux user ID running on the Linux, since both the applications are going to be running on the same operating system, so they should be having some way to differentiate them from each other. So, which is really, really logic, I think, logically speaking. So that's what should be happening. Yes. So the second thing that we should care about is understanding that beside the security boundary, we also have the user space and the kernel space. And I don't know if like I have explained those like concepts in the reverse engineering series, but I supposedly I have explained those things. So you should be just also, if you haven't like watched those this series of videos, then I would highly also recommend you watch that series of videos, which is also really interesting for people who are interested specifically about Linux applications and Windows applications too. Otherwise, so yeah, so this will be allowing guys the applications to communicate with each other, as we have talked about. So they need to go through the kernel space of the operating system. So each application needs to be going through the kernel space to be executing what's trying to do. For example, it's trying to access your data, so it should be getting by the kernel space, otherwise it won't be allowed. So as I have already told you in the first video, the kernel is going to be the gate with the hardware, so it's the one that will be responsible for doing anything related to the hardware. So the kernel is going to be responsible for that. Yeah, so this means that the application code, which is sandboxed in the user space, as you can see, so the application code will be relying here, and also will be communicating with other applications only after being granted like the privilege by the kernel. So the thing is that, for example, when the application A wants to get some privileges, for example. So it should be asking that from the kernel. So the kernel is the one that will be doing that for you. And the communication is done using the binder, as I have told you, which is you can just type in binder just to fully. No, what's that? Binder, okay. Uh, binder Android. Yeah. So binder API reference, which is this one, you can just have to take a look about that. So it's the term that I've been like talking about, which is the IPC communication that we've been talking about. So this also like the binder, which is also like implemented in the kernel space. So the kernel will also performs like some other important tasks, such as allocating the memory, triggering the use of the HAL, which is the hardware abstraction layer that we've been talking about in the previous video, and like reading and writing data to the hard drive, opening up the camera, opening up the GPS location. Those things are going to be done in the kernel space. So essentially, like the application processes will be staying in the user space, and for security reasons, all data and requests must be passed to the kernel, as I have already talked about. So to simply put, for people who do not know what user space is, so simply you can just think of it as a simple thing. So it's the part actually where the operating system will be running in user space rather than the kernel space. And specifically, it's the part where the CPU is going to be running on user space rather than kernel space by changing something we call a mode. So there is a user mode and there is a kernel mode, and you can just have to take a look. I don't know if you have read, guys, the practical reverse engineering, but it's pretty explained Well, pretty well explained in that book. So you just have to either. So I'm gonna be just putting uh, the name of the book right here for anyone who doesn't know that book. So one of the best books I have read, which is really interesting to explain to you how the CPU is doing its magic. So, and other thing you can search about is user mode and kernel mode CPU. You just have to read about these things to fully understand what I'm talking about. So the CPU is going to be switching from the user space to the kernel space, which is that simple. So but this so the CPU is going to be executing on the user space by switching up from the user mode to the kernel mode, which means that the IP or the instruction pointer is going to be just switching from the code that was in the application in the application itself and jumps to the kernel code. So that's it. So for the kernel space, simply like the kernel space is part of the operating system memory where the kernel and device drivers reside, I think. So it's the privileged mode of the operation in which the operating system kernels execute. So, for example, just to fully explain what I'm talking about, when a process is running in user space, requests, for example, a service from the operating system, such as reading or writing a file, the request is passed to the kernel space, where the kernel executes like the request and returns the result to the process in user space. You can just think of it as this thing. So, but like there is a question like how are the user space and the kernel space are isolated from each other. Like this is like when a lot of things are happening and there is a lot of conversions that is going to be happening where the instruction pointer needs to be like going to another thing, and there is another thing that takes then enters the game, which is the MMU, which is the memory management unit, and how your computer is managing, the memory and a lot of things. So I'm gonna be just skipping that part because you can just search for it on the internet. But it's a good question to answer to how those two spaces are separated from each other. Maybe I'm gonna be just letting this as a homework for you. You can just check it out. Yeah. So now just there is also another interesting thing which is really important to understand. Like suppose like you have an application that needs to store a file into for example a physical hard drive on your phone. So once you run the applications, like it becomes a process, as we have talked about, that lacks access to the hard drive. So to obtain access, the process must request permission from, let's say in this case, the God, which is the kernel space. So the kernel space is the God of your phone. So which is the operating system, as we have talked about. So the process going to be asking the kernel, hey, can I like use this hard drive, please? And like the kernel should be answering this question. So obviously, so in response, like the kernel communication with the hard drive and its drivers, like saying, "Hey, application X needs to say, for example, a file. Please store it with them." Like this conversation, like between the process and the kernel, happens frequently on your phone. Like in a how do we say this, in each second there's a communication between the application and the kernel and on your phone right now. So if you're watching this video from a phone, then I'm sure there's a communication that is happening between the application, which is the YouTube application, and your kernel. So be sure that this communication is happening right now too. So back to the example, like when the communication of or when the process is asking for is asking for permission to get to the hard drive, the kernel should be answering that question too. So it's like a beautiful thing to see the kernel like managing all the communications with the hardware and drivers. And now like we should be also understanding like the conversation between the process and the kernel. So how this conversation is happening, like this involves like a really powerful mechanism known as a syscall, which is I don't know. I think I have explained the syscall several times in the reverse engineering series, but it's great also opportunity to again recall the definition of a syscall. So a syscall is a way to let you communicate or let the application in the user land speak with the kernel, yeah. So it's kind of it's kind of a gate, I think. I don't know if it's a gate or not. I'm imagining this as a gate or a way to just knock on the door and say, "Hey, Colonel, can you please give me what I want?" And yes, syscall is a way to do that. So, like, this is like similar how person would request access to secured facilities just by going through, I don't know, security checkpoint. The kernel acts as the security guard in this way, checking the request against the static policies just to ensure that is valid, and then granting access if the request is authorized or not. So, like, in conclusion, access calls allow processes to make requests to the kernel, and the kernel then handles those requests and provides the necessary things that the application needs. So one way of doing this, if we can just take a look at that. So this is a way of how you can write to a file. You just create an output stream writer. So this is just a way to do that in Java. So you create a new object with the specific parameters, and then you just type in writer.write data writer.close, and it's over. So this is just a high level mechanism of doing this, but underneath that code there is some assembly that is going to be doing this syscall for you, and you can just go back and imagine how a syscall is going to be like occurring by you can just, for example, so let's suppose the architecture of the CPU is 64, and we have this pretty known table, which is how can you do a syswrite. So you would have to fill those registers are the RGI, RSI, RGX, etc. So I'm supposing that your phone is using Intel 64, but if it's using ARM, then that's another thing. Let's suppose it's using ARM 64. Yeah, it's using ARM 64. So if it's using ARM 64, then that's another thing. You just have to go and search for ride and understand exactly how things are going on. So it's going to be using X0, X1, X2, etc. So yeah, so things are changing with the architecture of your CPU, so you should be understanding at least how assembly is working. And I think I also made a video about, it's not about ARM, I guess, but it's a good opportunity to check ARM too. So maybe we add a video about ARM in this series too. What with with some practice too, just to fully understand how ARM is reverse engineered, and understand a little the instruction set, some of the few things that matter. So maybe in the Android native reverse engineering video, we dive more into ARM and try to include the instruction set as part of the video just to fully understand how ARM like is doing its magic, like the Intel 8664. Even though it's going to be not deep dive, but we try to see that too. So in this case, like as I have like talked about, this Java code will be trying to access the libc inside of this little native libraries, and the native libraries are going to be communicating directly with the Linux kernel just to make sure that we do this syscall. So this is, for example, some of the utilities that are from the native libraries. So another like question that could be asked, how can we trigger this syscall? And I think I've already like answered this question for you guys. So you can try that, for example, by trying to write some assembly just to fully understand how syscall is made. But for now, as I have talked about, like Java is going to be the high-level mechanism of doing this, but it's going to be talking with the native libraries that you have in your phone, and then the native libraries are going to be using like are going to be calling I mean the kernel, just to make sure that they do this syscall for you, so you don't have to talk directly with the kernel. So this is just a way to make sure that any casual person can do a syscall just by creating, for example, an application, or I don't know. So yeah, now one of the other reasons like we have to also talk about, which are like now we go into the we add more layers, like which are the managers. So the location manager, the telephony manager, the package manager, the activity manager, like they run as privileged users. So those managers specifically, they ran as privileged users. So how do we explain that? Like for example, certain requests, for example, such as, I don't know, accessing, for example, guys, the phone location, like sending SMS, displaying content, like playing sound, or I don't know, communicating with other applications cannot be accomplished like easily. So these requests require elevated privileges to access the hardware. Yeah. So, and this is the thing, those managers are not in the user space. To access like the phone location, for example, the application would use the location manager class from the Android API framework layer. So this is how things are going to be managing. So this is why we need a manager. So to make sure that the application is not communicating directly with the kernel, but yes, we've said that. We've said that the application needs to be communicating with the kernel, but at some point managers are made for that. So I can't let the employee directly speak with the client, so they need a manager to be just above them, so that the manager speaks with the client, which is in this case the Linux kernel, and the client is going to be giving you whatever you want, but through the manager. So the manager is going to be managing, for example, for the location manager, he's going to be managing the location for you. So when the application wants to get the location, it needs to speak with the location manager. So from the Android API framework. So the Android API framework is going to be including to you a lot of managers. So each manager is going to be having its own class. So this class is going to be related actually to Java API. So those classes are going to be managing things for you. So yeah. So for example, for the location manager service class, like it has a lot of things to do, but why do we need to forward the request to this service, for example? Like this step like will ensure guys the security of the process of accessing the GPS. But there is another question, guys, which is uh, we are like still in the user space, and there are like sandboxed from the kernel space, like to communicate with the kernel and access the GPS. We need the privileged service. So this will rise like the question of how this privileged actually service can communicate with the kernel. So while syscalls allows us like to communicate with the kernel, like we need another mechanism like to allow the location manager service to communicate with the kernel and access the GPS and get the data back to the location manager. So like again, this is where the Bender like driver comes in. So I delayed like the explaining of the Bender like mechanism just until now, guys, so you can just to make sure that I can explain it for you well. The bender, which is the one that I have talked about. So the bender, guys, is as I have like talked about it. So it's an inter-process communication mechanism like used in Android, the operating system, to facilitate like to make sure that the communication between the process and the system is occurring smoothly. So it is a high performance like mechanism. So now like there's a quick question that we can ask, like how does the communication like between the process and the service is done, or this specific service is done. So like this is where like a technique called like a remote process communication came into the game, which is which is basically like a technique for like inter-process communication, which is RPC. We call it RPC communication, or RPC Android communication technique. So you can fully just understand that, which is yes, remote procedure call or remote process like communication. So like the RPC is going to be used just by the binder that allows like a process to call a function or a procedure in another process or service, like our case, for example, the location manager service, and to receive a response. But how does like the communication between the location manager and the location manager service is set and involved in this communication? Because guys, there are two things that we should care about. There is actually a location manager and there is a location manager service. The service is the one that is going to be getting the information for us to the location manager. So we need to be understanding how this communication is happening and is set and configured, and how does the kernel gets involved in this communication since the binder is implemented into it, and how do we switch the execution switches like from being on the location manager to the location manager service. So this is where the binder like drivers comes in again, and it just will allow for the creation of client server architecture. So anyone doesn't know what this is, so client server architecture, I think it's pretty known. So you have a client and you have a server. So the vendor is going to be letting us implement this architecture between the location manager and the location manager server or service, I'm sorry. So you can just understand yourself who is going to be the client and who is going to be the server, I think. So it's pretty easy to know, I think. It's not that hard. So the location manager is going to be the client. The location manager service is going to be the server, and the vendor is going to be the mechanism that is going to be linking both of them together. So yeah, the vendor will use a system of proxies and stubs to communicate between clients and servers processes. So when a client process binds to a server process, like a proxy object is going to be created, guys, like in the client address space, the proxy object in the server process, but it's like actually, like just a local representation of the remote object, I think. But like when a client invokes, for example, a method on the proxy object, like the method call is intercepted by the proxy serialized, and serialization is another thing that we should be also explaining. But don't worry, I'm gonna be just explaining that for you later on. You don't have to explain everything at once. But now we are focusing on understanding the communication between the location manager and the location manager server and how the vendor is doing its magic. So yeah, so this object that I've been talking about is going to be sent across the vendor interface to the server process, and the server process then receives the method call, deserializes it, invokes the requested method on the remote object, and returns the result to the client or the vendor interface. So the vendor guy's driver is the one responsible for managing the vendor kernel module, which provides like secure and efficient communication channel like between the client and the server itself. So yeah, so it will also like provides additional like functionalities such as inter-process locking and synchronizations, a lot of things like. But I know there's a question like someone can ask like what is an inter-process locking and what is synchronization means, like if I recall that correctly, guys, if I recall that correctly. Okay. I think we've covered them in the operating system video and reverse engineering. I don't know if we have covered them or not. But anyway, inter-process locking and synchronizations are ways to make sure that multiple processes doesn't access or modify the same shared resources. In our case, it's the location manager service at the same time, which could lead to errors or unexpected behaviors. Like for example, back to the example of the applications. Application A and application B wants to get access to the location managers just to make sure that those application doesn't get at the same time to the location manager. We just have to find a way on synchronizing that, and this is where semaphore and a lot of other subjects are coming into the game. And you can just check out semaphore and synchronization. It's another class. Maybe you just have to go and check that out also, just to fully understand what I'm talking about. Yes. Yes. So what's next? Yeah. So we have an application that is running as a non-privileged process. So we have the application. It's going to be passing by the location manager dot get last location. The class is location manager. So it's going to be using a vendor proxy, vendor stop, which is the same as client server, is going from the user space to the kernel space using the vendor proxy as a way to save the information that's going to be receiving from the vendor stop. How it's going to be doing that using the Linux kernel, the vendor driver is going to be the mechanism to do that, to implement this vendor proxy, vendor stop, just using the interface. These are, you can just imagine them as two interfaces that is going to be receiving, sending informations from the location manager service that is running as a privileged process, that service in the kernel space. And congratulations, I think now you have some idea about how the applications are doing their magic, especially when you want high privilege access to a specific service. I think I have just fully just explained that for you, I think. But like there is also another thing, I've just explained some technical aspect. It doesn't mean that we have fully understood like the underneath of those, like, you know bender drivers and all of that. I know it's a hard mechanism. You can just, if you are more interested in that, you can just dive more deeper inside of the Blender like implementation by the Android, you can just check out the documentation to see that. But for now, we have just discussed the technical aspects of inter-process communication, such as the GPS example. It becomes apparent like that certain tasks like require the use of managers, as we have now seen. So these managers are just going to be part of the Android API framework, as we have also seen in here. Um, but they will just enable us to establish like secure and efficient communication with the kernel. Those simple steps. But perhaps like it's time now also to learn like more about those managers and their definition and stuff like that. So guys, a manager is simply used as the name of the class that is going to be responsible for managing specific aspects. For example, location manager is going to be the class that is going to be responsible for managing location. So it's pretty simple. So managers typically provide an interface for other classes or components to interact with. They handle the low-level details of implementing that functionality. So for example, in Android there are various we have different like system services that are implemented as managers, such as the location manager, the window manager, the audio managers. These managers like provide APIs for other parts of the system or applications to interact with. I don't know, such as, for example, the user location, managing window on the screen, controlling audio playback. In general, like managers are responsible just for implementing and maintaining, some certain functionalities inside of the system. So they just abstract away the details of how these functionalities are implemented, and just to provide a clean way of just of understanding exactly those high level APIs and those things. So as we have just talked about, we can just find a lot of managers. So yeah, we also have activity manager, I suppose, location managers, notification manager too. Yeah, there's a lot of managers now. As we have gathered all the necessary informations, we can now finally just answer the questions of how these applications communicate with each other on an Android service, on or an Android device. I'm sorry. So as we have like mentioned, now we have now the information that we need. We have the intents. We have. I think I have it. Yeah, the intents that we saw. Those are high level ways of implementing the communication between application. But the Bender is the low level part of how things are happening. For example, let's say this example run as a non-privileged process. Application A called start activity no intent b.x. So she's trying to call something, or she's starting to do an intent to another activity in another application. What's going to be happening? It's going to be going from user space to the kernel space for the Binder driver. The Binder driver is going to be calling the activity manager. So the activity manager is running as a privileged process service. And by the way, guys, this little guy right here is supposed to be in the user space, as you can see. And from the activity, so that will be creating something we have seen in this one, which is the Binder proxy for the activity manager. So don't forget that too. So the fourth thing that is going to be happening is going to be returning to the Binder driver, and then from the Binder driver is going to be to the activity b.x on create by using the activity manager service. So it's that one is running as a non-privileged process, which is obviously right because it's just a simple activity. And yes, this is the way you are trying to be calling another activity, just by making sure that everything is going to be secured along the way, making sure that the application A cannot be opening up anything beside the b.x, which is the activity b.x, just to make sure that, for example, when you try to call b.x, you don't try to, trick the driver, or not the driver, so trick the kernel to open up another activity for you. Let's say a malicious application that you have already installed inside of that phone. This makes sense, I guess. Anyway, so in terms of security, it's possible for an application to have unrestricted access to all of these managers. Like the answer is no. Like there are certain actions that that an application just cannot perform, such as, for example, opening up an internet connection, accessing the current location, or writing the to external storage, for example, SD cards, or I don't know, like whatever. So like this is where the Android permission system comes into play. So there's another thing that happens, which is the Android permission. Okay, we're adding things up. So there is also something called Android permission, and which already been right here in the manifest file. We will try to see that too. So Android just has like a lot of permissions, a list of permissions, so each of which protects like sensitive like capabilities, guys, such as the ability, for example, to perform certain actions like, I don't know, opening up an internet connection, sending SMS, accessing sensitive informations like users, contacts, locations, whatever. So yeah, for example, this is the code on how you can add permissions to your application. So for example, you just have to go, for example, this is the package name of my application. I have users permission, Android name, you do Android permission, don't send SMS, for example. By adding that one, my application will have the permission to send SMS. And when you install the Android application on your phone, my application has the right to send SMS to other phones. You should be understanding those things because actually Android relies on the user behavior, or I don't know how to explain this for you, but when you install an application, it tells you that this application requires permission to do that. Are you okay with that? When you type okay, you actually gave your phone to the application, so permissions are made for that reason. So yeah, so there are Android permissions, for example, send SMS, I don't know, internet, just to give access to the internet to the application, access network status to make sure that stays, I don't know, just checks out if you have internet or not, access to Wi-Fi state, read phone state, a lot of permissions. You just have to take a look at the Android permissions list, and you just have to go and read the API reference about that. It has a lot to give. For example, those are the permissions I'm talking about. You just have to check them out, I guess. Which permission is going to be doing something. So yeah, I guess. What else? So just to give you an example, guys, we need an example on that one. So for example, we have this permission. I don't know, like if it's in here or not. Read, yeah, read. I don't know. For example, right? Is there like read write? I don't know. For example, read. I don't know. Read whatever's like external storage permission, or I don't know. Like each application, as we have just talked about, like each application is going to be having its own internal directory just to save and retrieve data, and it does not require any permission to access its own directory. That's pretty obvious. Like, however, by adding this permission to the application, it gains access to the device external storage, which is the SD card. Well, I don't know. I think they don't use nowadays the SD card, but back in the days, they have been using this SD card as a way to explain or to describe the external storage, which was previously known, as we have talked about, as the SD card. Nowadays, like it's part of the file system that apps can use, like share files, and it is located at, for example, in a path in Linux we call I'm remembering that right. I don't know if it's SD card or something, but there is a path specifically into Linux like file system where you have the external like storage and all of that, where photos, downloaded files are stored. So it's important to note that no other application can access the data stored in an application internal directory, like unless the application explicitly just allows it to be exported. So we will try to see that part like in more details later on. But for now, we need to be understanding like those two things. Yeah. But to fully understand, like you can just see SD card file system and right just so you can understand exactly what I'm talking about. Is there like anything? So those ones are graphic one. Linux terminal picture. Is there like any terminal picture? Yeah, something like that. GF. Yes, not that one. Uh, 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 uh. Anyway, guys, there was just if you can just go and check that out. So there is some external way to see that. Yeah, so that's it. Now, for now, there is also another interesting thing, which is the permission of, like, for example, I don't know, like, if it's in here or not. System alert, yeah, this one, system alert window. So this will allow application to create window using the type window manager, like layout, prompts, type, applications, overlays are shown on the top of all other apps, which is this one. So you see this one when you have that, like, notification, and you have like messenger like on the top. When you click on that bubble, and then you see like you can be sending messages over that bubble. This will requires a permission, and messenger actually have that permission, which is this one. So which is system alert window. So that makes sense that permission aren't needed and required. So for example, we have, like, guys, four categories of permission protection levels that we should be understanding together. Like the first one, which is which is like normal permission, which is the first one. Well, the system, like, automatically grants the application that permission and at install time. Like the system doesn't prompt the user to grant like normal permission, and users cannot like revoke these permissions. So this is like, we are trying to say that like those are the standard permission that any application should be having. The second one, which is like the dangerous permission, this is like where you have to use a dangerous permission. Your app must be prompting the user to grant permission at runtime, which means that it pops up to you, hey, do you want to give this permission? So for example, when you install Instagram or Facebook, the first thing that you install is you install them with normal permission. And when you try to, for example, to post a story or a post or whatever, they're like, Instagram like prompts to you, hey, you want to give give access to your camera, and say yes. And at that point, you are giving Instagram a dangerous permission over your phone. So Instagram now can open up camera, open up mic, open up everything they want. So this is why, for example, Instagram and Facebook, when you try to speak about something and you try to see it in your feed, you're asking, why the hell am I having, for example, a computer in my feed? Because I have been speaking with my friend about the computer, for example, Alienware or whatever specific model, and then you see Alienware's computers in your feed. And you're asking yourself why. So simply because they are like snitching on you, or I don't know, they are like spying on you, that they are opening up the camera because the application you have installed in your phone are actually having that permission. So the next time you give permission to an application, you have to think. Be a wise user and don't give your phone to companies. Um, the third permission is signature like permission. Like those ones, like those permissions, like grant access to protected like system features or data only to apps that are signed with specific digital signature. I'm gonna be explaining pretty well what a digital signature is. Stay quiet, please. For example, like when the application requests a signature permission, Android checks the application digital signature to ensure that, for example, it matches like the signature of the application that was granted the permission. So this means that the only app signed with the same digital certificate as the one that originally requested the permission will be granted access to the protected feature or data. So signature permissions are commonly used for system level features that require high level of trust, such as access to the device camera or mic, or the ability to install or remove system apps. So this helps ensure that only trusted applications are granted access to sensitive features, and helps like prevent malicious applications like from accessing like user data or performing unauthorized actions on the device. Like for example, fun fact, like this is just a simple fact for me. Fun fact, like Facebook has been granted signature permissions from Android. So this is why gathering information for such an application is super easy. Be careful, like just the next time you install applications such as Facebook or any kind of meta applications. Yeah, the fourth one are special permissions. I know, like many people are are really interested in those permissions just to fully understand them. So special permissions are a subset like dangerous like gas permissions that require additional user action beyond simply just granting the permission in the application by running, hey, okay, 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 I want that. No, it's not like that. Like special permissions are typically just used by sensitive features such as making phone calls, sending SMS messages, accessing like the user camera, accessing the user microphone. When an application like requests special permission, the user must explicitly grant the permission, as through like system dialog. These permissions are also known as runtime, like runtime permissions, because they must be granted each time the application needs to use them, like rather than being granted permanently just during the installation process. Examples of special permissions include like make phone calls, access camera, system alert like window that when pops up using that bubble, like using Messenger or I don't know, Telegram or whatever, writing settings. Yeah, so if an application like needs one of these permissions, it must declare it in the manifest. So if you check the manifest file, you should be seeing those permissions and send an intent requesting the user's authorization. We will see like how to do like that in the next videos. Yeah, but in order like just to provide like more clarity, guys, some users are just granted automatically without any prompts or intervention. However, like dangerous permission need explicit approval like from the user and are only visible like on device with an API level of, I think, if I'm not wrong, the API level like should be from 32 or 23. I'm sorry, from the API 20 through 23 and above, like the user should be like having yeah, he should be approving those permissions. Yeah, yeah, I think that's it. So like well, in runtime like we have advantages like users. What I'm talking about, guys, is that just to fully understand what I'm talking, because I've been talking, I don't know if you've been focusing with me or not, but runtime Android. So this is like an example of what I was talking about. Allow permission to access photo and videos on this device. So this is special permission. Like the advantages are users can install apps without giving all the permissions. Like users have informations to decide accept or reject or whatever. Like permissions can be selectively enabled dash disabled. For example, you can use Instagram but without giving it permission to the camera. And we don't know yet, but as I have said, like Instagram, Meta applications are having signature permission, which means that they are already trusted by Android, which means that once you install them, they've been already having a lot of permissions on your phone. So be careful when you install them again. So yeah, disadvantages, for example, multiple prompts can be annoying to the user. So for example, many application can hijack many permissions. So the user might just say, okay, I will allow that, and then give the phone to the application, which is a really sad scenario where many people I know just doing that, which they do. Okay, I'm gonna be just allowing that so they don't annoy me and ask me again. No, it's okay. You can just let them keep asking you better than giving your phone. I think that's what you should be doing. So what about like install time? For the install time, so we have been talking about the permissions on runtime, but we have also permissions on install time. Like advantages like no annoying prompts, that's for sure. But for example, the other disadvantage thing is that all or nothing grant all permissions. You either give all the permission or the application won't install. So yeah, so I think we have like fully explained like the permissions. So this is the way of how you can like customize permission of an application. So for example my app permission, raw permission, and then you just this is just a way of saying like, hey, I'm gonna be customizing the permission that's going to be having like specific things: open camera, open mic, open whatever I want, and then it's just going to be calling that permission these things. And then you just have to add the protection level, which is a signature. For example, the permission group is just a way to saying that I'm going to be attributing, or I'm going to be just pointing out this raw permission to this group of permissions, and the phone should be just rechecking that raw permission when we are trying to install the application on the phone. So it's pretty straightforward, I think, and everything is as perfectly as well. We can also customize permissions. You can also, another thing it's like worth noting, that the system permissions are defined in the same manner as the other permissions. Like for example, guys, like to examine how I don't know, system application permissions are defined, we just have to take a look at the Android manifest as I have like told you. For example, this is a customized broadcast receiver. So the application is deadly receiver, so it's going to be doing deadly stuff. The permission name is deadly stuff. Intent filter is going to be doing like should. So just an example. That doesn't mean like the should is going to be doing something like the first line as I have like talked to receiver indicates that we are defining a broadcast receiver. The Android permission is going to be attributing like specific like custom permission that is going to be required to receive the broadcast. And the intent filter, guys, is the one that will be specifying the type of intent that the receiver is interested in. In this case, the receiver is just interested in an intent with the action should. So it's pretty simple, I guess. Overall, like this code is going to be defining just a broadcast receiver that is only accessible to application that have been granted the custom permission, and it responds to an intent with the action should. So yeah, so that's it. But you can just give me some time just to explain for you the use case of a custom permission, because you know someone might be asking why do we even have to use custom permissions of the application. Well, we need to be using custom applications because we need them. For example, signature, like the permission level signature, guys, is typically like used when a permission like should be only granted to applications that are signed with the same digital certificate as the application that defines the permission. That's for sure. Like this can be useful, guys, in cases where an application wants to grant access to certain sensitive functionality only to other applications that are part of the same developer suite of application. For example, Facebook, Instagram, Snapchat. Well, Snapchat is not a Meta product, I think, but Instagram, Facebook. What other application of Meta do we have? I just forgot. WhatsApp. Yeah, they are all signed with the same certificate. So both of these three applications are having the permission level signature. So for example, this suite of application will be using like the signature permission level just to ensure that only their application have access to sensitive user information. So if we go back to the dangerous permission. So the dangerous permission category is used like for permissions that could potentially like affect the user's privacy or the device normal operation. For example, examples of dangerous permissions include accessing the user contacts, camera, mic, location. You know, there are like geotechnical ways to implement permissions enforcement just to let an application get a specific permission that will let her do a specific task. The first one is just using permission group. So Linux groups, that's the first way just to implement permissions enforcement in the context of Android. So guys, Linux groups are used to manage and control access to system resources. You know, Linux groups is just a way of just organizing users and assigning them to specific access levels or permissions in Android. So each application run in its own process and is assigned a unique Linux user ID as we have talked about and a set of Linux groups. When an application requests a permission, Android checks if the application belongs to a specific Linux group that has been granted for the permission. So if the application does not belong to that group, then the permission request is denied. So it's simple as that, guys. It's simple as that. So the permissions groups are going to be helping us implement that using the concept of groups like in Linux. So we are trying to use as much as we can the potential that Linux is giving to us as an operating system to implement the permissions. So this is where the engineering is happening. For the other thing, which is aside from Linux groups, explicit checks, like the explicit permission checks are performed when the application like explicitly checks or requests the permission using the check self permission method. So this method, guys, will be which is one this one exactly, if I'm not trying to check self request, I guess. Oh yeah, permission. Yeah, it's just permission with the so this one, yeah. So this check, like self permission method, guys, is going to be the method that will be checking the application has been granted a specific permission or not. So if the permission has not been granted, Then the application can request it from the user using the request permission method. So explicit permission checks are necessary for permissions that are considered dangerous by the Android system, such as accessing the user location or whatever. So yeah, so just to fully can fully understand what I'm talking about. So for example, you have an application that is running as a non-privileged access. It will be trying to get the location manager. So getting by the vendor proxy, vendor stop, location manager service get last location. So and the vendor like RPC, the app requesting like access to the location will not be granted permission due a permission check performed by the service code. So this will be, the service code will be checking if the application has the permission or not before giving the location to the application. So the location manager service guys will be trying to check the level of the permission that the application have. Like suppose we take another application where like I don't know. We have, for example, this example of export the Android b.y exported true. You can export it, and the Android exported is equal to false. Like this is a really important. So the value of the exported attribute in the manifest.xml file in this application of the application B is set to true in this case, which indicates that we are allowing other application to access the component of our app. It's important to note that the default value of this attribute is always false. However, like if you define an enchant filter for the component, the default value is automatically set to true. So essentially, this means that if the exported like attribute is set to true, we are allowing the other applications to access the component whenever they want, so making it accessible to them. I think now like we've covered like the basics, guys, of how we are trying to explain the communication and the permissions, Linux groups, how Kernel is doing its magic, and those things. I think now we start a topic like more interesting, which is application signing. Yeah, it's time to understand application signing, I guess, to ensure the safety of the application against reverse engineering. So to fully just understand how this application signing is, so yeah, so we have application signing, which is this one. So yeah, we have the application developed and signed, and then it's signed using a signing key. Then we have like signed applications published on Play Store or whatever. So yeah, we achieve this by signing the application, and I think it's time to open up just Paint to explain to you this one. So you have the application. Uh, you have just right there, develop it. Everything is working well. It's time to publish it. So you need to sign it. Why? You need to sign it, guys, because if you don't sign, your application is not going to be accepted by your phone, which is your Android phone or your Play Store in general. So certificates. So they achieve this, guys, by signing the application with the certificate. So a certificate is consisting just of a public key and private key. So you just have to generate two keys. So you just have to generate the first key, which is going to be public key, uh, a public key, and I think I've explained that part, which is just part of the asymmetric like encryption. So we have two types of encryption. We have symmetric encryption, we have asymmetric encryption. Symmetric encryption consists of using the same key for encryption and decryption. For asymmetric encryption, we use the public key as a way to encrypt the data. We use the private key as a way to decrypt the data, but in this case we are using another technique, which is signing data, which is making sure that no one tampers the data that we have created. So for example, if you have an information, let's say this one, so it's private, so private key. So for example, if you have like a message that is called I don't know, like iron, for example, you want to make sure that when you send this message from A to B, that B gets iron and not gets, for example, hacked, or someone tried to change the iron from iron to hacked. So there's a man in the middle right here, this little guy that is going to be changing the message, right? try to change the message or temper it or modify it along the way. So to make sure that B can check if the data is tempered or not, we create something with the message we call e-signature. So that is going to be taking the message, um, do some magic on it, some math actually. Just it's going to be using, that's the thing, it's going to be using the private key. It's going to be using the private key, and it's going to be signing the message using the private key, and then send with the message the public key that will be helping us to you know recreate the signature. And then and then uh, once it gets to B, he will try to recreate the same signature from the message that was received by B, and then compare it with the signature that was sent with the M and the public key. And the question is, how do we recreate the signature? It's just by using the public key that was assigned with the certificate. So that's how it's done. So it's pretty simple, guys. It's not that hard. So this certificate is going to be including actually the public key, the message, which is actually the binary of the application, the APK, and the signature. And that's it. And also another metadata informations about the author of the application, such as its name, the company, when that happens, stuff like that. We just call that metadata, so it's not that important for us. But what's really important for us is the public key, the message, and the signature. And actually, this actually will be really important to know, especially when you try to sign an application, especially when you try to temper an application, which means that you try to patch it. Patching applications came to the part where you are trying to change the original code that was in there by trying to put your own code. So when you try to do that and you rebuild again the application, so the goal is to dissect the application into pieces, change what you want to change, and then rebuild the application back again. So when you try to rebuild the application again, this signature, well, actually the binary of the application, the APK, is going to be changed. So the signature won't match the public key that was in there with the message. So that's why this application won't be installed on the phone that you are trying to test on. So that's why you need to be re-signing or signing back again the application with a new public key and a new signature that you can generate yourself. I'm gonna be trying to say that or show you that, and you can create an example in next practical videos where we try to patch an application. For example, for educational purposes, we try to just play a CDF challenge around that thing just to show you how things are going to be working specifically for that one. Yeah. So another thing that I want to talk about aside from signature signing in this video is also about certificates, specifically the SSL certificates. SSL certificate. So this little SSL certificate, which you can find in here too, which is saying that the connection is secured and all of that. So it's really important. Well, certificates are used to establish a secure and encrypted connection between a client and a server. It also ensures that the data is transmitted between the client and the server, and is protected from eavesdropping, which is pretty known attack, I guess. Eavesdropping. It's just when someone is trying to listen to what are you trying to send from your client to the server, which is pretty known. So the SSL certificate is going to be issued by a trusted third-party certificate authority, and contains information about the certificate holder, the certificate expiration date, same as the one that I have just talked about right here for the application. But this one is going to be for connections, just to make sure that the client and the server are communicating in an encrypted way. Yeah. So on the other hand, app signatures are used just to verify the authenticity, the integrity specifically, just to make sure that no one tampers the data of an Android application, as we have talked about. But app signatures are generated by the app developer and are as we have talked about, like the difference between SSL certificate and Android application certificates is that application Android certificates can be generated by me, by you, by anyone. So if you try to temper, yeah, an application, it's not hard to sign it. You just have to generate two keys, public key, private key, and then just sign that application, and it should be installed on your phone. So it's okay. Doesn't have any issues. But SSL certificates is complicated because you can't recreate the certificate, because the only trusted certificates are from the third party certificates, which means that you should be like having some certificate installed on the server, and you cannot go into the servers of other like companies and install your own certificate. So that's the issue, I guess. So I hope like I have provided like a clear explanation for you on application permissions, application signatures. Like these concepts are really important, guys, for you to understand exactly for you to understand exactly how things are going to be working. But I want to also give another examples of how. So for example, this is an example of two applications that shares like the same user ID. Just I want to emphasize the way on how the user ID mechanism that I have talked about is actually implemented, which is a really important thing that I want to also show. For example, this is for the first application where you have like Android shared user, the same way as like you have this little one, which is permission group, just have something also called shared user. So shared users, for example, these two applications are sharing the same user. Uh, this is also another example of how you can set up the resource example. For example, you have this was example called string secret string, which is juicy secret. For example, you can access the resource in Java with that one. So resources dot string secret string dot secret string. So this resource is shared. So if the application can just call that one inside of the code, then it can get that juicy secret, for example. Yeah, so the next thing that I was also try to explain for you is how dynamic code loading is working, because it's a really important thing to talk about too, I guess. So runtime, guys. The runtime, yeah, it's about the runtime. Can we try to create a code that can be loaded on runtime and executed on runtime? So it's a quite an interesting guys method, or quite an interesting concept, because you might already like be familiar with it, I know, but this method is quite famous in C, where for example it has like a similar like counterpart, like we call it a system, and then we call, for example, dash bin dash bash, just to call back the bash executable to be running commands. So in Python it's also as os.system. So in Java we are going to be using something called class loader. Yeah, we are going to be using class loader, or also, if I'm not wrong, it's runtime exec, and you just have to give it the command. So yeah, if I'm not wrong. Um, this will essentially, guys, will create a new process, thereby creating a new process within the process that has been executed. That's for sure, and executing like the command there. But like, how is it going to be doing that exactly? Well, internally, like the exec is doing how do we say this? Exec is going to be using a syscall to execute just a command or a process. It creates like a new process and executes it like in the specified command, and it's implementing this, guys, which is the runtime. Exec is implementing a fork. I don't know if you know what a fork is, but a fork and exec v system calls, I think I've explained them pretty well in the reverse engineering class. I'm pretty sure I've explained them. But yeah, but like I'll take the initiative and explain them for you another time, just to imagine you can just imagine that like the fork function is going to be creating a copy of the current process and just returns the process ID of the new process to the parent process. So you actually have something like that. So this is like the parent process, and you have like the child process, which is going to be creating using the forks is called. So this is the main application, and this is like the new code that you are trying to load. You're going to be loading that inside of a new process. So once the child process is created, the exec v function is used like to replace like the child process memory space with the new program. So this function next takes the path of the program to be executed as the first argument. And you know, guys, exec v is pretty known. I think I have tried to explain that. So it's one of the few uh, it's one of the few things that the execution of a program, if you go back to the video of execution of a program, a high level perspective, you'll see that I have explained pretty well what the exec v is going to be doing before going or jumping to the kernel code of the operating system and executing actually the actual kernel code. So this new program will run within the child process like separately like from the parent process. Well, the programmer like who codes these two functions deserves a prize, guys. Like one thing, like to mention about the runtime exec is like you need to be having the Android permission dot internet like permission. So this is like because this runtime this runtime exec can be used to execute arbitrary shell commands which could potentially access the internet or perform other actions that require permission. For example, like if you try to execute a command to start a web browser, or the web browser would have the ability to access the internet to load web pages, or I don't know, like for example wget or whatever, like curl or whatever. So everything like is chained in your phone, guys. That's what I want to explain to you. That everything is chained for you. Another concept that is called also reflection is going to be using this one. So which is like an interesting feature in Java that allows the program to examine and modify the behavior of an object at runtime. Yeah. So the question is like, what is the difference between creating an object on runtime and creating an object on compile time? So creating an object on compile time makes it like you see you can imagine this as in C or C++, where you have the assembly is already like pre-implemented there for you. You just have type in upstamp and you see like the assembly of the function that you have already compiled. But when it comes to Java, guys, like Java also have this functionality, which is a reflection. So using a reflection, you can just inspect classes, interfaces, constructors, methods, like fields of the object at runtime. And you can also create new objects, invoke methods, modify fields like dynamically. This makes it possible to write generic code that works with objects of different, classes, and create new objects of classes that are not known at compile time. Like, however, reflection comes with some disadvantages, guys. Also, we can also such as performance, complexity, security risks too, which means that malwares can use that a lot too. Can use a lot of reflections as they want to, for example, execute specific code at runtime. They won't let that fell inside the compile time, because if it falls in the compile time, maybe the antivirus will detect them. So using the dynamic code loading, we will make sure that we can create something out of that. Yes, so it's going to be requiring, additional runtime checks to ensure, like, type safety, stuff like that. So, yeah. What else do we have? So now we can also talk about other interesting things. So that's the thing. So when you see like that one, uh, that interrogation like point where it's not knowing what class is. So this is what inflection is about. You can just search more about that if you want. Another thing like I want to talk about now is something that we have like delayed, which is like the serialization, I guess. Yeah, the serialization. Okay, like you just simply just to explain for you, when a process is converting an object into, for example, when you create a class, let's suppose you have this object, which is going to be person x is new person, and you want to send this person acts to another application or to another computer, or I don't know, this person to someone. You just wanted to send this person to someone. So this is where like serialization comes into the game. Just allows you like to take the object and transform it into a format that can be like saved on disk, or I don't know, sent over the network or stored in a database. Like serialization is just an important concept in programming because like it enables developers to work like with complex, data structures. Yeah, and just pass them between the different parts of the program, between different, between different things. Like even those programs are written in different programming languages. Like the serialized object can be read and reconstructed at any time, even by another program running on a different like machine. So these there are like different serialization methods such as binary serialization, XML for example serialization. We have also JSON serializations. Like each method has its own disadvantages and advantages, that's for sure. Like the choice of the serialization method depends on the specific use case and requirements, and like that's it. That's just depending on the serialization method that you wanna know about. One more thing to talk about is the intent. So in Android, like we can use a high-level mechanism provided by the Android API frame, because we have talked about just the intent. So make sure that you can start an activity. So it's going to be using the binder outside of that one. So we can like we can like add request code. Yeah. So this is the special things. Like for example, from application A to application B, component X colon component B, we can add request code, which is 400. We start the activity for result I, we wait for the request code. So caller can use request code to distinguish replies from different requests. On activity result, you have to enter the request code, the result code, and the intent data. You check this the request code and the result code. If they are the same, then you just have accepted that data, otherwise you reject it. So it's pretty straightforward. So you just have to understand those things, I guess. Yeah. I guess like now we have like fully understand the security part of the Android, guys. Now what rest is one thing is that we should be just finishing this video with. I hope you have like added some new knowledge to your head, I guess, by understanding those little facts about the Android. Now I guess you have a bigger picture about how the Android is doing its things. You have like the Linux, the process, user ID, shared ID, permissions, intents, how they are working, Binder specifically, the low-level mechanism that is going to be letting the communication happens between the application A, application B. Now, what lets us is that we need to be routing the device to be able to work more or to have control over the device. So, just to show you can fully understand what I'm talking about, is that you need to be installing something called AVD, which is Android Debugger Bridge. So, if you don't know how to install this, you just have to go into Android platform tools. I'm gonna be just leaving that in the description so you can install those little tools, and then you have to choose which platform you are using. If you are Windows, you just have to install Windows, Mac, Linux, and then go to the environment variable, and then go into variable environments, and then go into the path one. You just have to modify it, and then you just have to add the platform tools. You know path inside of this one. It's just you have to press OK, reboot your system, and then you're just gonna be able to do this, which is ADB. Just call it directly from the command line. Now the thing is that ADB is going to be letting us actually check this little phone that you can see in here, which is the emulator or the AVD that I'm having. I'm actually having two ones. One is rooted and the other one is not rooted, just for the case of this one, just to showcase to you how you can root your AVD, because it's really important, as we have talked about, just to see, for example, since right now I don't have like the AVD rooted, but as you can see, when I type in ADB devices, I can see all the devices that are attached to this service, which is ADB server. So if I try to run ADB shell, As you can see right now, I'm in the Linux partition of the little Android phone that I have. I type in ls, I can see like the files, the everything, the folders inside of the this little phone. But if I try to do like so, just make sure that I'm changing to root, saying that inaccessible or not found. But if I try to exit and start ADB as a root user, saying that ADB cannot run as root in production builds. So that means that we should be rooting this little guy right here. So the first thing that you should be doing is I'm gonna be just leaving that GitHub repo in the description so you can follow with me. Just have to follow this guy. Follow this guy. You just have to clone this little guy right here. It's going to be just doing the magic for you. So I've already like I think cloned that one, I guess. So root, not this one, like root AVD. So you have this little one. If you are using Windows, just type in root avd.bat. So you're using like Linux, you just have to use like add the execution to your file just using root avd.sh, and then you just have to run it on Linux, and it's just supposed to be asking you for root permissions to install some stuff, but it should be working. But if you are using Windows like me, you just have to write in root avd.bat, and just it will just pop you this little list right here. You just have to take the first one and type it out, and it's going to be installing some kind of application inside of the inside of your AVD emulator of Android, and this application is going to be the one that is going to be installing like Majestic for you, which is an application that's going to be taking the lead on your phone to if the AVD doesn't shut down, try it manually. I suppose it should be like shutdowning, I guess. Yeah, it's shutdowning. Yeah, okay, so we wait a second. We see if it's going to be working. I guess we should be trying to. Medium phone is already running. If that's the case, delete it. Okay, maybe it's going to be restarting alone. Okay. Pull majestic.apk into that one. Okay, maybe I'm having an issue right here. Maybe I need to be restarting the application, maybe, I guess. Okay. We try another time. Okay. Maybe if we try to open up or restart Android Studio. Okay. We try another time. I suppose now it should be working. No, it's the wrong one. It's the wrong emulator. So this one is already having like I guess this one is already having Majestic installed on it. This is the one that will be taking like the root lead on the phone. So no, that's not the one. Can you shut down this one, please? Yeah, thank you. I want to open this one. So this one is not does not want to open. Medium phone is already running. Why? ADB devices. It's offline. Why it's saying like it's Anyway, guys, I'm not gonna be like wasting too much time on that one. I'll just show you exactly what I'm talking about. So once you install once you run that script, it should be installing this application for you, which is Majestic. So once you have that one, you just have to type in ADB devices. Now I'm having two things. If I try to ADB shell, so I just have to kill the server and restart again. ADB start server. ADB devices again. ADB shell. Okay, it's I wanted to connect to a specific one, which is this one. Can I have the IP address of it, please? More than one device emulator. I don't know, like I have to go into just a second, okay, we just don't have too much time to waste it. I just have maybe to close the processes completely from my computer. So Android, Android Studio, ADB devices, like go back and right here for this one. Try to run ADB. They're still in there, I guess. AVD maybe. I just have to find out the process that is running and just kill it, specifically for the other emulator. So yeah, ADB devices maybe still there. Device offline. ADB kill server one more time. ADB kill server one more time. ADB start server one more time, please. ADB devices. ADB devices. Yeah, so we're still like having that little guy right there. So I need just to restart my computer. So anyway, for now you just have to follow this little script right there. It should be rooting your device. Otherwise, if you're using BlueStacks like me, also BlueStacks can be a good way of having your device up and running. So you just have to go there and to fully like root your BlueStacks device. You just have to go into this one, Blue NXT, which is located in your program data, and then you just have to be having BlueStacks NXT installed on it. You just have to go into BlueStacks and then search for rooting or root access. You just will find it as a 0. You just turn it as a 1, and yeah, this one too, little one here, just have to put it as a 1 too. Just put in 0, but you just have to switch those little 2 values right there, I guess. Once you have that, let's try for example with BlueStacks. Maybe I can show you that. What are you expected to be having exactly? App player, I guess. Yeah, the app player is trying to be run. Okay, the app player is running. It's waiting for run. Okay. We try to go using ADB devices again. Okay, it's not in there. It's good. If you go to advanced, the first thing they should be like checking this little guy right here to say that ADB is allowed, and then you just have to connect to this little address, this little local address, which is ADB connect 107 0.0.1, and then the address is 5558, and now it's connecting. Now if we try to do ADB shell, should be okay. It's the same issue, which is that I'm connected to many devices. So the issue is that I'm connected now to many devices. Now I should be the thing is that I don't know why kill server ADB start server is that I don't wanna. Okay, we'll try to connect again. Can you please? Okay, like I suppose like same issues that I'm still connected to. I don't know how can I like ADB more than one device emulator. So how to detach myself from a device? How ADB? How to detach from a device. Maybe there is like something. ADB-S service device name disconnect. Okay, ADB-S. This little one here. Disconnect. Disconnect everything. Okay, if you try to do Y. Yes, but I wanna like also disconnect from this one. Instead, I want this one. It's disconnecting from everything, but it's still like just showing this little device right here, which is okay. Like if we do like now ADB shell, what do we get? I'm trying to debug this. Okay, it's now. I suppose it's communicating with this little guy right here, which is the BlueStacks, because the other one is closed. Okay, now like if we try to do ls, we're still having this one. If we do su, now I'm actually I guess I'm should be I should be like root I guess, but it's not working. But if we do like adb root, if this works, that means like yeah, it's still connected with the other emulator, which means that the emulator is still running I guess. I don't know exactly. I need to close the process of the Android Studio to fully show this one. But if you try, if the phone is rooted, then when you try Who Am I, you just simply have to see that you are now root, not a simple user. So you just make sure that you try to check that out when you try to root the device. This little root right here is just your guy. Just have to see that one. Yeah, I guess this is the end of the video. So I hope you have learned something new out of the security stack that we have just I have just explained for you. Don't forget to follow me on Twitter too. Don't forget to hit the sub button. And yes, the next video is going to be building up more about the APK. I guess next video is going to be diving more inside of what the APK is having. So just have to stay notified with the series, I guess. So see you all next week. Bye.